All right, everybody, and thanks for tuning in to the Daily Space Weather video. Lots of ground to cover tonight, including whether it's the solar kill shot or not. Should you be in a bunker? We'll tell you about it. By the way, this filament right here, I've increased my pointer size and changed the coloring to make it more visible. That filament, between half and two-thirds of that, is now on the way to Earth. We can expect a sustained CME impact. Is it likely to destroy civilization? There is just about a 0% chance of that. So, now also fair warning, folks, there is a possibility that our video tonight could induce seizures and things. So before we move on to our solar imagery stuff, because there's an SDO roll maneuver and some bright and crazy looking images. So just so you are aware of that, if you are prone to having issues with visual stimulus, well, that warning was for you. So there's the past 24 hours, and we've decided to get up close and personal with Sunspot 3664, which is in your lower right, because it's where the action has been. So over the past week, as you can see here, it has been pretty active. So we put up a 1 week video for once here just to show you how active. Just a massive uptick in the X-ray flux. For the past 24 hours, the X-ray flux has been an average of over an M-class output. So typically, when it drops back down to baseline levels, sure, it is below an M-class level. However, counting all the flares and the duration of the flares, average flux is over an M-class rating for the past 2 days. So it's, and of course, another CME on the way from this morning. It erupted at about 5 a.m. Universal Time. And it's almost perfectly earthly directed. So it is perfectly directed from the perspective of stereo A. So it's a few degrees off being perfectly earthly directed. Keep in mind, Earth is moving in the direction of stereo A, sort of in the same direction that you see the sun rotating here. So that's... Anyway, there's Sunspot 3664 up close. We're showing that is the SDO HMI continuum. So that's basically the raw sunspot data there, similar to what you'd see with visible light, as well as the 131 angstroms ionized iron wavelength. And yes, there are 2 X-class flares in there. One quite a bit bigger than the second. Here we've slapped together some other stuff while we're looking up close at Sunspot 3664. That's 171 plus 304 from the SDO's AIA instrument. Ionized helium plus ionized iron. The 171 is the 60-minute running difference, if that's not complex enough for you, but that is some pretty funky imagery indeed. Here we've put together 1600 plus 171 60-minute running difference. And there has been a lot of carbon hanging around the surface of the closest star. So that's what 1600 angstroms is. There's the extreme close-up. And yeah, so yet another CME, which makes it 5 as of this morning, as far as I could tell. And it looks like we agree with Tamitha Skov. I mean, I saw a tweet from her, and that looks like about right as far as my count goes. Now, some of those might overtake each other, so you might not see 5 signals, as CMEs, coronal mass ejections, can do funky things as they dissipate through space. There are unseen features out there that can alter their course and so on. So anyway, let's briefly, very briefly, so that filament right there, it's now on its way right here. And if you enjoy the content, make sure you press the like button. If you're new to the channel, make sure you press subscribe. Otherwise, how would you get the world's most comprehensive daily space weather content delivered directly to your YouTube subscription feed? I guess you wouldn't. You should probably follow us on social media also, as there's all kinds of important stuff regularly disseminated on there. These images are from the SDO Browse data site. Let's take a brief look at what's going on planet Earth. A very brief look. That volcano in Iceland is still erupting, but just barely. It is producing some outgas. You can see some gas there, some smoke and so on coming out. Here's your volcano list. Our viewers prefer that we show this. Those are the erupting issues at the moment. And yeah, I'm not calling out any volcano names. I don't want to lose my voice. I'm taking it easy, as it might be a very long weekend. Seismic activity is low at the moment. These are the quakes of a 5 and greater magnitude for the past 24 hours. And only Vanuatu had a 5.1. I think that's the only 5 and greater magnitude quake. And yes, I know people claim all the time that space weather is able to forecast earthquakes and so forth. I don't see it. I would invite anybody who makes such claims to forecast an earthquake. Just forecast one in a believable fashion. And then explain how you did it, right? Make it a repeatable thing so you can forecast earthquakes. That would be great. Who's doing it? Nobody? A heaping helping of nobody. So the 10.7 centimeter radio flux, a very important feature of where we are in the sunspot cycle. Basically the same important as sunspot number. The same importance there. It's currently at 227 solar flux units. There it is in a convenient one-year chart. You can expect to see higher highs and higher lows for the next 5 months, and similar levels for the next approximately 10 months, because we're expecting solar maximum in approximately 5 months. You see, solar cycles are extremely predictable in terms of their length, probably for millions of years, according to things we see in the fossil and geologic records. Anyway, here is our Space Weather Enthusiast dashboard, and you can see they're now forecasting a G4 class geomagnetic storm. So I don't know what went on there. I just got an email about this. NOAA is now forecasting a KP8+. So I would tend to agree, but again, it always depends on the magnetic fields. So also, like I said earlier, we've got 5 CMEs on the way. One, I think, is just in the process of arriving now. It's a very weak glancing blow style impact, so it's probably more like 4 at the time I made this video. But yeah, there's like 5 on the way, give or take the one that's currently striking. Of course, any sort of nature video is by nature slightly outdated by the time it gets recorded and uploaded. So it looks like NOAA has upgraded that forecast to KP8+. So G4 class geomagnetic storm is actually in the forecast now. I did press refresh on the website. It has not updated there yet. They're expecting the impact early in the day on the 11th. So Sunday morning around midnight local time U.S. So we might see some major fireworks. Be prepared to see the aurora. Be prepared to see the aurora. Late night Saturday night into Sunday. It couldn't be more perfect timing for auroral viewing. We're hoping we get clear skies here, in which case we'll be at a place looking up, hoping that there's some weather from space, with the appropriate tripods, comfy chairs, and so forth. So yeah, that's a thing. Impact coming early in the day universal time. Now, NOAA's forecasting it a little bit earlier than ESA. ESA, the European Space Agency, is forecasting it to arrive at about 6 o'clock in the morning on Sunday. That's universal time, 6 o'clock universal time. So, like I said, early in the day on Sunday. 6 o'clock universal time is like 1 a.m. Eastern. Now, another thing that we should probably mention is an important thing pointed out here by Sarah Husial, who says, any impact to power grid and satellites as a result of the storm will be mitigated by operators, likely going completely unnoticed. So yes, the storm may cause, in first world nations, things like brownouts and blackouts. Is it going to burn up the power grid? Very, 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 very unlikely, because these things are there are fail-safe mechanisms that detect too much induced current in the system. When there's too much induced current in the system's shut down, whether either manually or by automated electronics. So it's very unlikely your transformer, like on the pole at your corner, is going to burn up because operators shut down the systems before that occurs. Now, I have heard a lot of nonsense about some guy called Ben Davidson. Is some football player. I guess he's retired, and now he talks nonsense about space weather and cosmology and geophysics and tells people that the universe is electric or something and the sun is shutting down and all this insane, utterly nonsensical crap, and that he's built a cult compound in Colorado and things. It sounds crazy, but I mean, I don't know. Maybe a bunch of Raiders fans are also into space weather. Can anybody comment on this? Anyway, but right now it's pretty calm in the Earth system. But don't expect that to continue because, again, like I just said, there's like 4 or 5 CMEs on the way, at least 4. And one of them is a major impact from just this morning. And yeah, it's quite earthly directed. It's a few degrees off to the west, but keep in mind, Earth is moving to the west. So that's what's going on in space at the moment. Things are still calm. And on the ground level, things are calm. So there it is, the past 4 hours of Earth's magnetic moment from the ground level. This depicts magnetic flux density in terms of geospace delta B. That's changes to Earth's B field. This field being the field that goes through the magnet, this magnet being Earth. And as far as the power grid goes, we are seeing some minor fluctuations happening here, some power induced, but not a lot. So this is a great way to see when the aurora is likely to be overhead at your location. The U.S. and Canada geoelectric field map showing the empirical data in millivolts per kilometer. Millivolts per kilometer. MV/km, millivolts per kilometer. Why can't I say kilometer? All right, anyway. Yeah, no bloopers reel. Those are in, what is it called? B reels? Those are A reels because we record these videos in one take. KP index is currently at 1.33. Of course, we used to do the videos live. Again, it's geomagnetically calm. We're expecting it to come way up here to KP8+. Significant possibility of that. So, may see the aurora as far south as Alabama, according to NOAA's latest email alert. So that's pretty good. Fingers crossed for that. There'll be a lot of people tuning into space weather, saying, hey, space weather's awesome. Wouldn't it be cool if some channel could do actual accurate forecasting of it? Wouldn't that just be fantastic? Of course it would be fantastic. So here's what's going on as far as the measurements at the ACE. And like I said, there is a little CME impact right here. You see a field fluctuation. You see a change in the plasma temperature and the density and the velocity. So that looks like a minor CME impact, like a glancing blow, like I explained later, like I explained earlier. And as far as the Discover, it looks like that's waning there at the Discover. We are seeing a bit of a varying series of signals there. Currently 6.67, which is probably 666, rounded up, right? 6.6, 6.6. That's what math nerds say when there's a repeating decimal, 6.6. Are you spooked yet? Oh, you should be spooked. Actually, that's not a spooky density. If it was like 666.66 protons per cubic centimeter, that would be a scary high solar wind density. But it's not. And the plasma speed here, just over 400 kilometers per second, 416 kilometers per second. There is about a 0% chance that civilization will be destroyed from the incoming space weather. Just about a 0% chance. GOES magnetometers remain smooth. Look at that for days. Just a chill sine wave going on there, roughly. Just it's space weather calm. North Pole magnetic sector is where Earth remains. And by tomorrow's daily space weather video, Earth will still be in a North Pole-oriented magnetic sector. That's my forecast. Here is our line of sight field plot. And I'm not super excited about this stuff, so I'm moving on to our coronal hole line of sight plot. We'll have some South Pole-oriented coronal holes rotating in here in the east, as we showed yesterday. Nothing new there. They'll become more well-defined in the coming days as the corona is kind of bumpy. Sunspot number now around 170. 170 sunspots is the sunspot number according to Rob. The Royal Observatory Belgium. The likelihood of X-class solar flares remains very high, especially from sunspot 3664 and still from sunspot 3663. So don't forget about it. It is not out of sight yet. It still needs another 18 to 24 hours to be completely out of range of being able to produce an X-class flare as detectable from spacecraft around Earth. So, I have to make that caveat because once these things set over the far side of the sun, then they can start producing flares and we can't detect them. It's not to say they're not flaring anymore. They're not producing detectable flares. And of course, many of us really wonder if flares are anisotropic, meaning if viewed from different angles, do they appear at different intensities? That would be nice to know. Too bad stereo A and B don't have an X-ray sensor on them. That would be great. Because if flares are anisotropic, it tells us something else about heliophysics, which I won't get into because this video is already going to be lengthy because of the massive amount of solar imagery we have. So let's go to sunspots. Oh, we'll show coronal holes. I almost forgot. Dear God, don't let me forget to show coronal holes. There you go. You'll also see a rippling across the surface of the sun at the same time that a flare happens. It's kind of going to go right behind the Earth scale and just kind of propagate across most of the Earth side of the solar disk there. There it goes. And of course, many people think such wave-like features are an indication that the sun has a real surface, not an illusory one. Another thing I won't get into in great detail on today's daily space weather video. But that's a great view for coronal holes, 211 angstroms from Solar Dynamics Observatory. So, all right, sunspots. Sunspot 3664 is legit. And it hasn't degraded really at all since yesterday. That's a 24-hour video. That's just today. It's almost 20. That's like 20 hours. Here is the full disk view. Oh, yeah. Oh, yeah. Good stuff. And of course, since we've got especially rowdy behavior, why not include the 171 angstroms plus colorized magnetogram? How you like them apples? That's what's going on to date today on May 9th. May 9th, 2024, a historic day for space weather. Here are some rotating field of view close-ups of 3664. Gotta have it. You can see it hasn't really changed much at all since yesterday. It's going strong. That is a 24-hour video, so maybe a little bit of modest growth. Certainly no significant degradation. And the magnetic shield, the magnetic shear remains extremely high. You can see lots of areas there with white and black side by side in extremely solid fashions. Those are where you'll find deltas if they're both associated with umbrae, and many of those are. Too many to even point out individual ones. You can see it for yourself. A picture says 1,000 words. And before we get to CMEs, dag, it's too early to get to CMEs. I guess that is kind of important, but let's talk proton events. They're more likely to happen with sunspots on the western limb, as we have now. And indeed, we have a proton event. It's a minor one. It's probably not causing any radio blackouts yet. But if that increases just a little bit more, we'll start to see some polar radio blackouts. Polar radio blackouts, especially at the North Pole. They might be starting to set in, but I don't think so yet. That looks a little bit too low for radio blackouts. So there are the past couple of days there. That's about 48 hours. Let's show the 3-day. And yeah, that's a pretty substantial uptick in X-ray flux for the past couple of days. And before we get to that, what are we missing? What are we missing? We're missing something. A solar system forecast. So, here's where things are today. There's where things will be in a week. On the 16th, we'll be just past first quarter. We'll have a gibbous waxing moon. This is what's going on overhead, Lehigh Valley, Pennsylvania, as Mercury's chased by Venus, chased by the Sun, chased by Jupiter, chased by the Moon to the horizon tonight. That's from skyandtelescope.org, by the way. Today's astronomy photo of the day is the massive radio source at the core of Galaxy M87. So this has two relativistic jets, one of which is somewhat oriented toward the Milky Way galaxy. That would be the one right here. The other relativistic jet oriented somewhat away from the Milky Way galaxy. And of course, M87 was made famous when the widely circulated image of the, quote, supermassive black hole, end quote, at its core, which is the origin point of those relativistic jets, was shown all over the internet. The, quote, first image of a black hole, end quote. apod.nasa.gov is where to find it on your own if you like. And there are a bunch of links there if you want to read more about M87 and the relativistic jet associated with it. You want to go to a place of very high cosmic ray flux? Go to the source of that jet and get in the jet. You'll find that there is kind of a high cosmic ray flux in that location. A little bit higher than at Earth. CMEs. CMEs are almost like cosmic ray flux, as they are protons, mostly protons. And don't get them confused with flares, folks. Solar flares are photons. You know, X-rays? X-rays, very different than protons. Protons are primarily made of hydrogen gas. So, ionized hydrogen gas is what a CME is made of. A solar flare is X-rays. Did I explain that adequately? Hopefully. So, CMEs, and you see one that looks like a halo there, that's because it is headed directly at the aperture. This aperture being the SOHO spacecraft's LASCO C2 coronagraph. And yeah, it's an Earth-directed CME, and it's very Earth-directed. Not quite as perfectly as directed at stereo A, but we'll show that. So here we've stopped this at 10 o'clock this morning. Oh, I think the CME originated about 9 o'clock this morning. Yeah, it did. The filament blasted off around 9 o'clock this morning. And there it is. There's the halo. And there are some other events there, but it's looking like a long duration CME impact. So this one could last from about midnight local time in the eastern U.S. all the way until Sunday morning and beyond. So that'll be interesting. Again, hoping for clear skies in Lehigh Valley. Now, sometimes it's better than other times for CMEs to happen because we have things like the Solar Orbiter and Bepi-Colombo or the Parker Solar Probe in between the Sun and the Earth. But as you can see, they are not there right now. They're way over here toward Venus and Mars and things. And that's not helpful because it doesn't allow us to measure anything before the solar wind shows up at Lagrangian point 1, which is only about 1 million miles away. And as you can see, those orbits are much closer to the closest star. So, no additional data from them, and check it out. From Stereo A's perspective, it is almost exactly directed. Look at the way it looks like it's unfolding. Just fantastic. That is the best halo CME that we've ever shown on the channel for pushing 6 years. of the world's most comprehensive daily space weather content. There's a planet there, too. I think that's, is that Jupiter? I want to say that's Jupiter, but I don't care, and I'm definitely not going to look it up. But there is a site where you can look up what planets are visible on stereo A. If you do find out, let us know in the comments. But yeah, look at that halo. I'm going to let that play through once on the difference imagery. That is just spectacular. Dag. That is like almost perfectly directed at stereo A. Again, that's this filament. That filament right there, that one could have gotten a name. And if you would have named it after your friends, your foes, or even yourself, you could name the geomagnetic storm after that person too, because it's, you know, it's them showing up at the magnetosphere, really. Knock, knock, knocking on the magnetosphere's door. All right, so let's show our custom coronagraphs because they are spectacular. You got SDO in the center. You got LASCO C3 in blue. You got LASCO C2 in red. And yeah, that's... I'm speechless. So there is an SDO roll maneuver in there also. You know, compliments to the SDO crew who's able to do that roll mechanism and keep the image as close to not bouncy as it is. It's pretty impressive. And of course, the reason we use the SDO for this imagery, folks, is because many of these wavelengths are not visible from Earth. They have to be viewed in space as the atmosphere adsorbs those extreme ultraviolet wavelengths like 304 angstroms, 193 angstroms, difference imagery, which we're showing here. Not visible from the ground level. That's why coronal holes weren't discovered until the early 1970s. So yeah, lots of stuff going on. I'm not going to try to explain it, but there it is. And that is a wrap for some serious solar imagery today. So yeah, cheers. Thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. Let's cut through the rest of the bonus features and meteorology and get this thing onto your screens. So yeah, filaments. There they are from Cerro Tololo's ground-based solar observatory. We got a bunch of large filaments rotating in. Look at how huge that one was that is on the way. Again, 1/2 to 2/3 of that have blasted off. The rest have remained positioned up there in the north-central hemisphere. So that could blast off, and it's a fine example of how you can have a CME not associated with a solar flare. Because remember, they're separate phenomenon, and they're completely unalike. Coronal mass ejections are protons. Solar flares are photons. Moving right along, and there's another CME coming out of Sunspot 3664 as we make the video. So, yeah, at least a prominence. So there's probably a radio burst that I'm getting an alert about. Let's see. Am I getting an alert about a radio burst? If my phone would just function, it might tell me. All right. Nope, not yet. But it certainly looks like a radio burst. Here's a forecast for you. If you sign up for NOAA's email alerts, expect an email alert about a radio burst. And look at the size of that prominence rising up over the eastern limb. Dag. Look at that thing. That would be your screen upper left. The GOES 16 SUVI depicts the past approximately 2.5 hours of solar activity. Yes, there are people for NASA that are paid to have that on their screen all day long. Get a BA in astronomy and you can work for NASA. It's true, folks. It's true. Charging hazards. We ain't got none. It's smooth sailing for satellites at the moment. Electron flux here coming up off the floor briefly. It's going to drop way down according to that because it's going to be an erroneous reading because of major CME impacts. Pow! Pow! I do stuff on the vehicle scale. There are the past year data for the relativistic electrons. They're measured at the F layer of the ionosphere. There's a forecast model, and NOAA's expecting an uptick. They weren't expecting that CME impact, though, so they'll change the forecast because they'll be way off. Anyway, once again, the layer where it's measured is the F layer. And there is the ionosonde for that layer. The F layer, it could be considered the bridge between Earth and space, and we're going to see some major anomalies in the coming days. At the moment, things are pretty calm up there. Things are looking pretty nominal, average, kind of boring. But that'll change. Right now, you see a fairly even mix of low and high frequency anomalies as depicted here on the anomalygram. Anomaly in megahertz from a 30-day median. Yes. Yes. And almost done with space weather. Now, if you want to see where the GPS errors are going to be happening, check out the total electron content. That's going to give you some ideas. Now, we don't show the forecast anymore because the data started to look like it was crap. So we're showing the global ionosphere nowcast instead. And but you can infer from this where they're going to be, depending on the northern versus southern hemisphere and the nighttime versus the day to night transition versus the night to day transition. They are associated with that, and same with the maximum usable radio frequency. Dag, we got to move on and blast through meteorology because this video is going up early. So there's our latest SDO continuum, a little bit of sunspot growth there in the northeast, it looks like. But the beast, it looks like, sunspot 3664. Yes. Very nice. Very nice. And here comes meteorology. Oh, and by the way, if you want to name filaments after living people, just follow the hashtag #NameThatFilament over on Twitter. And tag us in the post. Just tag us in the post. Type hashtag #NameThatFilament. Edit it on your phone. Put a little arrow that says which filament you're trying to name. And maybe even one day I'll decide to follow this human on Twitter. Next, we're looking at pressure. And check it out. There's a mixed bag down here in the Southern Ocean. We've got very high pressure and very low pressure side by side. Side by side. Now, in the southern hemisphere, high pressure systems rotate counterclockwise. Low pressures rotate clockwise, as you can see. The world's lowest pressure, by the way, is right there. That is hurricane force low pressure in wintertime. In other words, the weather is probably less than hospitable right there. Let's check the temps. Yeah, it's 24 degrees. Not too bad. It's not like the Antarctic and mainland where it's negative 70 plus Fahrenheit. So, anyway, yeah, that's the current pressure situation. You've got this huge anticyclone right here, sort of off the coast of Argentina there. And yeah, besides that, things are pretty chill. Things are pretty chill. Are you seeing any sunspots causing hurricanes? Let us know in the comments if you're idiotically seeing sunspots forming hurricanes. That's not a thing, by the way. Yeah, it's not a thing. Sunspots don't cause or behave in any way like a hurricane. Hate when people say idiotic things on YouTube, and then people come on our channel and they leave comments, and they say the galaxy. I'm spooked of the galaxy. You to be spooked of the galaxy. The galaxy spooked of my fist. All right, so here is what's going on in terms of wind patterns. The surface winds of the eastern world, for example. Jet streams. Jet streams, anyone? Jet streams of the central world What about the surface winds? Of the west? What about the western jets? Well, there they are. Next, satellite. Because we include value-added services in the videos, we don't just make accurate forecasts about space weather. We make accurate forecasts about things like actual hurricanes when they make actual landfall and actual things like actually that. Actually. Here's a satellite for the U.S., and it's gloomy. Gloomy, I tell you. We're hoping things clear up for Saturday night and Sunday morning. Windy.com. I'm not paid to tell you that they've got a great mobile app. Or to tell you weather.gov is where you can get a bunch of weather warnings. And we've got a bunch, like Jersey's going to flood and turn into the sewage capital of the U.S., while strong storms will hit the southern states, like Texas and Georgia. And the ones that are depicted there. Here's the forecast, 72-hour GFS pressure and precipitation. 72-hour GFS accumulated precip in inches. Positive snow depth change in inches, GFS 72-hour model. Colorado, the hot air capital of the U.S., will also be the snow capital of the U.S., with some areas receiving nearly a foot. Temperature anomaly forecast in degrees Celsius. Same model, GFS, same time period, 72 hours. Again, it's in degrees Celsius, which means the Pacific Northwest is going to have a lot of degrees throughout some large portion of that forecast. It's could be an actual heat wave. Lightning's next, and we had some lightning move across the southern states. Let's see if we have any current strikes with lightningmaps.org, powered by blitzachtung.org. Go ahead, say it aloud. I dare you. Dear Gond, what happened to my pointer? Oh my Gond, my pointer. Lightningmaps.org don't like my pointer. Look at that. It's giving me the finger. It's giving me the AI digital melted finger treatment. And we have some thunder rolling in at Savannah, Georgia. Next time you hear thunder, check out Lightning Map. Well, I don't know why I'm even telling you that. I don't care. I mean, definitely don't get struck by lightning because that doesn't tend to be survivable. But lightningmaps.org, when you hear thunder, it's just awesome. Gloomy, gloomy skies over Pennsylvania. Here's our satellite imagery. There is our water vapor map, some rapid cloud nucleation happening in Texas, which will be prompting people to think that they're man-made clouds. It's HAARP clouds. By the way, that's another reason to join us on Twitter. There are some hilarious chemtrail plonkers. We're bringing back the word plonker, so join us over there on Twitter just for that hashtag plonker. There are lots of plonkers on Twitter. That is a word that cannot go out of circulation, and if you think it should, then you, sir or madam, are a plonker. Or non-binary person, you are a plonker. Don't be a plonker. Join us on Twitter, x.com/smashomash. So this is your recap if you haven't noticed, which ends with your water vapor map, which clears up your Doppler if you haven't noticed. Oh, what's going on with that? How can that be? It's because of rapid cloud. In other words, when you get wet ground and then you got dry, high pressure, hot air above the wet ground, the water from the ground gets into the air. Through evaporation and convection, you have things like clouds form. And that is that. Anyway, hopefully we'll see you over on X or Instagram or something sharing auroral images soon. Once again, congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And as I head back to the bunker, pardon the sarcasm, may that solar wind be at your back. Whoa!